Hi class. So today I want to cover the function and TV loan worksheet that is um, within the guided worksheets. So one last time, I just want to remind you how you can download the worksheets if you didn't purchase the workbook. If you go to my lab and mastery, and then click on this button to launch to the eText home course home. Right. So then you'll notice here on the left there's a tab for guided worksheets. So you can click on that and then click on this link to download as a PDF. Right, so here are all of the worksheets, right? All the pages. So I downloaded them into OneNote so that way I could write on this for lecture. So again, I want to go over the function and TV loan worksheet. So it's on page 5 in the workbook. Right. So the main content of this worksheet is from section 1.1. So the main idea is looking at what a function is, right? So at the top here we have a definition. So a function is a relationship between quantities referred to as inputs and outputs in which every collection of inputs is paired up with one and only one output, right? So you may have seen an example of this, maybe like in a beginning algebra class, right? You might have briefly talked about what a function is. So typically in an algebra class, we talk about a function in terms of a numerical sense, right? So you may have seen like a mapping where like here, maybe I have my inputs here, so inputs, and then maybe over here we have outputs. Right? And then maybe for inputs, my options are 1, 2, and 3. And maybe for outputs, my options are 7, 8, and 9. Right? So if I draw an arrow from 1 to 9, right, that means 1 gets mapped to 9. Right? 1 is my input, and then my output becomes 9. Right? So we can draw this diagram to show inputs and outputs. Right? You've probably, like I said, probably seen this before. Right? So if we had something like this, every input, right? My inputs are 1, 2, and 3. All of them are being mapped to one and only one output, right? So 1 goes to 9, 2 went to 8, and 3 went to 7, right? So in this situation, this would describe a function, right? So let's look at an example where something would not be a function, right? So again, I'm just thinking about this in the numerical sense for now. Um, so if I had this box of inputs and this box of outputs, right? So let's still use 1, 2, and 3 for my inputs. We can still use 7, 8, and 9 for my outputs, right? So let me use blue to show the mapping, right? So maybe 1 gets max to 7. 1 also gets mapped to 9. 2 gets mapped to 8. And 3 gets mapped to 9. Right? So this would be an example where we don't have a function. So in this case, the way to think about it is 1 can have an output of 7, but it can also have an output of 9, right? So this would not be a function, right? So every input can only have one and only one output, right? So if we have an input, we cannot get more than one possible output out of this, right? So this would not be a function, right? Not a function, right? Good. But one thing to note, though, is that more than one input could go to the same output, right? So let me show you what that would mean. Right, so again, one last time we'll do inputs with outputs. right? So we'll still use 1, 2, and 3, and 7, 8, 9, right? So it's okay if, for example, we have 1 being mapped to 7, 2 being mapped to 7, and we could even have 3 being mapped to 7, right? This is still a function, right? So every input has one and only one output, right? So maybe my output's being repeated, but that's okay, right? So basically what we're saying is if I input a number, I can only get one thing back, right? I don't want to be able to have more than one option back. So this would be a function. In fact, this is a special type of function that you should have learned about in the text. This is called a constant function that's described here. Right. So if you recall, as you're reading in the section, right? So a constant function, as described in the text, is a function for which the output is the same or constant for all inputs, right? So for every input, you get the same output. So there is only one output, for example, right? So an example of this is if we are mapping a senator to the country of residence, right? That would be an example of of a constant function, right? So let me write this down. Oops, too far. Right. So if I were to map senators, so we input a senator and map that to the country of residence. Right. Then we would get a constant function, right? Every senator would be mapped to the United States of America, right, as our country. So there's only one possible output, right, for every input in that case, right? All right, so let me go ahead. I'm going to erase this on the left. I think I can try this. Right, so just making some room to try the problem in the worksheet. Right. All right, so in number 1, it says determine which of the following are functions, right? So we're given this table where we go through with different inputs and outputs, and our job is to determine if this would describe a function or not a function, right? So for the first example, we're given inputs and outputs. So the first row, the input is a state, and the output are the senators for that state, right? So you may have to do a little research if you don't know what how the senators work for each state, right? So what you would find is that every state has 2 senators, right? So exactly 2 senators. So if I think of it in this sense, right? So if my input are states, right? So if my input are states, so for example, if I have the state of Ohio, right? Then if this is my input, there are 2 senators for Ohio, right? We have Sherrod Brown and Rob Portman, right? So in order to show this mapping, if I input Ohio, then there are two possibilities, right, for that. They can be mapped to two different things. So this would be an example where this is not a function, right? So if I have one input, I can have more than one output. So if you pick any other state, right, if you pick Florida, you pick Michigan, so forth, if you input any of these states, you're always going to get two different outputs for each state, right? So this example would not be a function, right? So we would say no. So this would be a no, right? Right. So let's look at another example. So this is flip-flopped, right? So now what we're saying is my input and here's my output. So we're saying the input are senators, right? So we could have Brown, Sherrod Brown, and Portman, for example, from Ohio. Then over here we have an output, right? So maybe Ohio is here, Michigan, so forth, right? So we would have states listed. So if I input Brown, that's going to be mapped to Ohio, right? If I put Portman in as my input, that's going to also be mapped to Ohio, right? Let's see. So I don't know the senators for Michigan, right? But we could look that up really quick. Let's see, senators for Michigan. Right. So we have Gary Peters and Debbie, maybe Stabenow, maybe how you say that. So here we could have Peters. And Peters would be mapped to Michigan, right, and so forth, right? So we could list all 100 senators and map them to their states, right? But if you think about this for a minute, if I input a senator, it's only going to give me one output back, right? And that's because you can't be a senator for two states, right, at the same time. So this would be no, or excuse me, this would be yes, right? So this is a function. This would be yes. Right? So every input has only one output, right? Exactly one output. Right? All right, so let me erase some more. All right, so the next row, right, we still have inputs and outputs, right? And drawing these diagrams is just helpful just to think about if something's a function or not, right? So this is called mapping, right? Mapping a function. So my input here are states, right? So I'm going to have states here for my input. And for my output is going to be number of senators, right? So in the states, I could have, Ohio, Michigan, Florida, and so forth, right? And number of senators, right? We could have like 0, 1, 2, 3, right? We could have numbers over here, right? So the mapping would look something like this, right? So Ohio has 2 senators, right? So Ohio would be mapped to 2, right? Michigan would also be mapped to 2. And Florida would also be mapped to 2, right? Because every state has 2 senators. So every state that we input is going to be mapped to 2, right? So every input will have only one output, right? Actually, they'll have all the same output each time, right? So this would be a function. This would be a yes, right? In fact, this is a special type of function that we talked about. This is called a constant function, right? Constant function meaning not changing. So we have the same output every time. So my output is not changing, right? Good. So then now let's look at the next row. So we have people being mapped to anyone they've been married to, right? So one way to think about it is, can you think of an example where this would not be a function, right? So if here are my inputs and here are my outputs, so input and my output, right? And over here we have people, and here we're matching who they've been married to. So been married to, right? So maybe here we have John, Frank, Sally, right? Maybe over here we have, I don't know, Scott, Diana, and Suzanne, right? So think of an example. So if we're getting anyone they've been married to, right? Maybe John has been married twice, right? Maybe John was married to Diana, and then John secondly married Suzanne, right? So maybe this is his first wife, and this is his second wife, right? So this is an example where we're inputting a person and getting two different outputs, right? So that's not uncommon, right? Not unheard of for someone to be married more than one person. So this would be no, right? This would not be a function, right? And we're talking about this in general sense, right? Not a specific sense, right? So what you're asking yourself is it possible for someone to be matched up with more than one output where your outputs are who they've been married to? And the question is yes, right? Someone can be married to more than one person, right? Not at the same time necessarily, but could be married to more than one person over the time period, right? So then the next row is people matched to the number of spouses, right? So the number of spouses that you've had. So if you think about this for a minute, right? So let me change this just a minute, right? So let's say we still have the same people, but our outputs now are the number of spouses that you've had. Right. Right, so number of spouses. Right? So we have 0, 1, and 2. I'll do. Right? So Frank maybe had 0 spouses. Right? John, we saw, had 2 spouses, and maybe Sally has had 0 spouses. Right? Then this is a function. Right? So every person is only going to be matched with one number, right? There's going to be some number out there that exists that describes how many spouses that you've had, right? So this would be a function, right? There's a single number for every person, so this would be a yes, right? So the next example is U.S. citizen mapped to Social Security numbers, right? So what you want to think about is, could a person have more than one Social Security number, right? Could they be mapped to, let's say, 2 or 3 Social Security numbers? And the question is, or the answer is no, right? Every U.S. citizen gets exactly and only one Social Security number. So this is a function, right? Every person gets one social, right? Let me erase. right? So a way to think about this is if this box is my inputs, which are US citizens, right? And then over here, this is where my outputs live, right? And here we're mapping it to Social Security numbers, right? So here, let's say we have, I don't know, Tyler, John, and Sue, right? Then there's going to be one social here, one social here, right, so forth. I'm not writing all 9 digits just to simplify, right, just to make a point across, right? And let's say we have another social here, right? Every person is going to get one and only one social, and it will be a unique social, right? So Tyler will be matched with 1, Sue will be matched, or John will be matched with 1, and Sue will be matched with 1, right? Everyone gets one and only one Social Security number. So the answer here would be yes, right? So then, well, excuse me, I already marked yes for this row, right? But this is also true for the next row. So if we think about it in reverse, Social Security numbers going to U.S. citizens, that will also be a function, right? So in reverse, if I take a Social Security number and map it to the U.S. citizen that belongs to, that's only going to give me one and only one person, right? So if I randomly pick a Social Security number, I know for sure it's going to be matched with only one U.S. citizen, right? And in fact, when this happens, so notice what happened here is we just reversed the inputs and outputs, right, for these 2 rows, right? So inputs and outputs were reversed, and both were a function. Then this means that this is a special type of function, right? So when this occurs, when we can swap my inputs and outputs in both ways give a function, this is called a 1-to-1 function, right? And again, this was covered in the text, right? So you want to make sure that you're reading the definitions in the text before you're watching the lecture videos. Right, so remember I teach this class in a flip format. This is true even on campus. So students are reading the textbook before they come to class. And then we talk about the material and do mathematics in class. So I'm just replicating what I would do in the classroom in this online video. Right. So then the next row here is people to birthdays. Right. So if I input a person, am I going to get only one birthday? And of course the answer is yes, right? Every person only has one birthday, right? You can't have more than one birthday, and you can't have 0 birthdays, right? You can only have one birthday. So this has to be a function, right? So then the next line flips that, right? So what if we go birthdays to the people born on that day, right? So in other words, again, the question you should be asking is if I input a birthday, let's say, I don't know, June 1st, right? So if I input a birthday of June 1st, am I going to get more than one person born on that day? And yes, we would, right? I mean, if I input any day, I'm going to get hundreds of people, right? If not more, born on that specific day, right? Depending on if you look at just U.S. people or so forth. But so this would not be a function, right? This would definitely not be a function. This would be a no, right? So then the next row is students in the class, and that's going to get matched with shoe size, shoe size, right? So if I pick a random person in this class and I map that to shoe size, you know, how many mappings will that go to, right? So if I pick any random person in the class, right? So let's say, I don't know, Ashley, right? If Ashley gets matched to Sue size, right? So here we have students in the class, and over here we have shoe size, right? Maybe we have Ashley, John, so forth, right, in the class. Then over here maybe a shoe size of, I don't know, 8, 10, 12, 13, so forth, right? So each person only has one shoe size, right? So Ashley may be matched with 10, right? John may be matched with 12, right? But the trick is your foot is just one size, right? It's being matched just to one shoe size. So this would be a function, right? This would be a yes, right? So then the last row um, is swapping that, right? Um, so, or no, it's sort of swapping it, right? So we're doing shoe size map to students in the class with that shoe size, right? So if I input a shoe size, let's say 10, then it's going to give me back the students who have that same shoe size. So would that be a function? And in general, this would be a no, right? Because we could have more than one person with the same shoe size, right? So for example, maybe I have Sue here who also wears a size 10, right? So if I reverse the mapping, right, if I do the reverse order, go shoe size to students, then if I input 10 here, I'm going to get an output of Ashley and then also of Sue, right? They get mapped two ways. So that would be more than one output, right, if we reverse the order, right? So hopefully this helps. So we're thinking about a function in very general sense, as you can see, right? So then number 2 asks us, can you come up with a function between two quantities which remains a function when you switch the inputs and outputs, right? So in other words, can you come up with a one-to-one function, right? That's another another thing that we're looking for here, right? 1, 2, 1, right? So I have a couple of examples, right? Maybe you have the inputs of maybe degrees Fahrenheit, right? And your output is degrees Celsius, right? This would be an example that fits into this, right? If I input a temperature in Fahrenheit, it's only going to get mapped with one temperature in Celsius, right? And vice versa is true. If I pick a temperature in Celsius, that will get mapped to exactly one Fahrenheit temperature, right? Another example of this could be maybe your inputs are the number of gallons of water, right? And your output is maybe the weight of the water, right? So this would also be another example, right? If I could come up with an equation essentially, right? And if I can determine the number of gallons of, if I know the number of gallons of water, then I could figure out the weight of the water, or vice versa, right? If I know a weight of the water, I could use that information to figure out, well, how many gallons of water do you have, right? So this would also be true, right? There's many different examples that you could think of here, right? As long as it can go both ways, right? Be a one-to-one function, right? So you may have had a different example than mine, right? So then on the next page, so a lot of this page is going over some key financial literacy vocabulary for loans, right? So you want to read over this and make sure you understand this terminology, right? So we have principal, interest, period, balance, interest rate, annual percentage rate, or we can denote that as APR, periodic rate, and then lastly, annual percentage yield, right? APY, right? So again, you want to make sure you take the time, read over these in the worksheet, also in the text, and try to get an understanding of the vocab, right? And we'll work through some problems that'll utilize the vocabulary, and hopefully that will help you as well, right? So here we have a credit card loan example. So it says, let us assume you buy a Sony flat screen TV for your dorm room that costs $1,000. You make the purchase with a store credit card that has a 12% annual percentage rate, APR, right? You do not have to make any monthly payments for the first year. Sounds good, but they will charge interest at the end of each month. how much do you owe at the end of the first year, right? So this is a very common thing that you know, different stores will do, like Best Buy, for example, like where you can buy something interest-free for a year. Um, but again, the catch is if you don't have it paid off by the end of the year, then you have to pay interest over the entire time period of the loan, right? So we're just going to explore what this would look like, right, after the first year. So number three, the first thing is it wants us to identify the principal, right? And if you remember from the vocab, the principal is the amount of money borrowed from the lender, right? So how much you borrowed. So we borrowed $1,000, right? So $1,000 would be the principal. And then for number four, you're asked what is the monthly interest rate, right? So this is something that was in the text, right? We were told we talked about a periodic rate, right? So periodic rate, the equation for this is you take the APR, the annual percentage rate, and you divide by the number of periods in 1 year. Number of periods in 1 year, right? So in our case, my APR is 12%, right? That was given in the problem. And we're trying to figure out the monthly interest rate. So how many periods are in a year? If we're talking monthly, right, there are 12 months in a year, right? So there would be 12 months in 1 year, so we divide by 12. So 12% divided by 12 would leave me with 1%, right? So this would be the monthly interest rate would be 1%, right, in this case. So then looking at question 5, it says, what is the interest charge for the first month, right? So an equation for interest, right? So interest is equal to the periodic rate times the balance, right? So in our case, the periodic rate is 1%, right? That's what we found it to be, right? So I want to multiply that times the balance, which my balance for the first month would be $1,000, right? So if I take 1% times $1,000, we get an interest of $10, right? So this would be your solution for number 5 then, right? $10. That's how much interest was charged, right? So then after question 5 here, we're given a screenshot of an Excel document, and we're given just some information, a cell reference handbook, right? So we're given 4 different cell references, and we're told some information about it and what type of cell reference it is, right? So there are 3 types of cell referencing, right? So we can have relative cell addressing. We can have absolute cell referencing, and we can have mixed, right? So mixed is a combination of relative and absolute, right? So that means you're not locking in both the row and the column, right? In my previous video, we looked at how to make a multiplication table in Excel, and we explored some absolute and mixed and relative cell addressing in that, right? So this is something that you definitely want to make sure that you understand is cell referencing. It's really important, right? And don't forget there is chapter A in the textbook that can really help you with the Excel part, right? So I might review that for the cell referencing if you're having trouble with that. And also, if you just go into YouTube and just Google like Excel cell referencing, like relative cell addressing, I'm sure that you can find a lot of hits, a lot of helpful hints on there as well, right? So highly recommend, if you're not understanding something, don't give up, just keep trying, right? That's part of learning. It's all about persevering through it, right? So here for relative cell addressing, we're given the cell reference just A4, right? A4. And what we're told is that changes the row number when you fill up and down, and changes the column letter when you fill left or right, right? So there's no dollar sign signified here, so nothing's going to be locked in, right? So if I fill up and down, then my row number is going to change respectively, right? And if I fill left or right, then that's going to change the column, right? So then here we have the first one's a mixed, where I have a dollar sign in front of A, right, for the second row. So this dollar sign in front of the A is going to lock in the column, right? So no matter how I fill it, the column will not change, right? So if I fill up and down, the row will change, but if I fix left and right, the column will not change, right? And so the third row is very similar, where here the dollar sign locks in the number, right? So if I fill, so it says here, right, if I fill up and down, the row number will not change, right? That's locked in. But if I fill left and right, then the column will change as I fill, right? Then lastly, the absolute. This is where both the row and the column are locked in. So no matter how I fill this, up, down, left, right, everything is fixed. It won't change, right? All right. So now I want to open up an Excel document, right? So let me kind of go split screen here. Right. All right, let me zoom in. Right, and I'm gonna replicate this screenshot, right? So in cell A1 and B1, it looks to be merged, right? So I'm gonna merge these two. Right, so remember we can highlight those cells and hit merge in center, right, to merge those, and it combines those into one box, right? So then it says buying a flat screen TV, buying a flat screen TV, right? Something to this effect, right? And notice that my word is cut off, so I can make this bigger, right? So that way we can see the entire thing, right? And then in cell A3, we have where it says month, and then we have balance, interest, and then new balance. Let's see, and then in cell F1, right, we have 1,000, and then 12%, so 0.12, and then, oops, I don't think this needs to be over 1. So let me move these over 1 to the right, my bad. So F1 is where we want it to be principal. Whoops. Right, and then we have APR, right, so annual percentage rate, and then the period, right, which was monthly, and then we have number of periods in 1 year, right, listed, well, see, he just wrote number of periods, and then in 1 year was the cell right below, right, with a colon. Let me make this there a little bigger. So then lastly in cell F6 we have periodic rate, right? So then for number of periods in a year, right, we would put in 12, and then so this is formatted as currency, right? So I can go up here and hit the dollar sign, right, to format that as currency. And then this is formatted as a percent, so I can come up here and then hit the percent sign, right? So format that as percent, and then it looks like we're in good shape, right? So to calculate the periodic rate, remember I need to take the APR, so we need to hit equals first to tell Excel I want to do formula, and then click in the G2 box, right, to reference the percent, and then I need to divide by the number of periods in 1 year, which is cell G5, right? So I'm going to take cell G2 divided by G5, right, and hit enter, right? So we get 0.01, right? And I can go ahead and format that as a percent also, right? So that way I remember what I'm using that to represent, right? So the benefit of typing in this cell reference like this is, let's say my APR suddenly changes, right? Maybe I'm able to get the loan for 8% at another store, right? Then I could just type in 8% into here, and suddenly now everything is recalculated, right? So the benefit is when I use cell referencing, if something ends up changing, right, one of my inputs are changing, then I don't have to go and find and fix every little time that I use that number, right? So cell referencing is the powerful thing in Excel, right? So remember, this was 12%, right? And when this switched to 8, right, notice that it's still 1%, but if I show more decimals, it's clearer that that was not 1%, right? So if I change this back to 12%, notice I get exactly 1, right? So sometimes in Excel we have to show more decimals to understand that there was a change, right? So let me decrease these decimals back, right? So we want 1%. Right? So now we need to fill in the rest of this column, right? So question 6 says, what formulas in cell C4 and D4, right? So we don't know what these are, but we will fill those in, right? So first let's fill in the months. So I want to start with month 1, and I want to go all the way to month 12, right? But I don't have to enter in 1, 2, 3, and so forth. I can use a cell reference. So I can hit equals and do the cell above plus 1, right? So this is a relative cell addressing, right? And then I can fill this down until I get to 12, right? So the relative cell addressing says, hey, whatever cell you're in, take the cell above it and add 1 to it, right? That's what this formula is said to do, right? Take the one above it, add 1 to it. I didn't lock anything in. So when I drag this down, like if I look in cell A11, for example, right, it's taking the cell right above and adding 1 to it, right, which is what I want it to do, right? I want to collect the numbers 1 through 12. So Excel is doing exactly what I wanted, right? So then to know the balance, right, that I have, again, I want to try to enter in the least amount of numbers as possible, right? So these box here, right, so let me put this as a color, and I'll add all borders, right, just so it has the lines, right? So you can think of this, these are kind of like my inputs, if you will, right, into this function. So anytime I can reference these, you want to reference these boxes, right, anything in these boxes. So I don't want to input a number here and for balance, right? Because I can just hit equals and reference the cell G1, right? So what that'll do is it's saying, hey, copy whatever number is in cell G1, right? So then suddenly, if I'm like, man, I really want to buy this $2,500 TV, right? I can just input it in one spot and notice it changes here also, right? So that's going to be really powerful, as I was demonstrating before, right? So then we're trying to figure out, so what's going to go in cell C4, right, which is listed here. So remember, I told you a little bit ago, right, to calculate the interest, you take the periodic rate times the balance, right? So I would want to take equals, right? So the periodic rate would be cell G6, right? But the thing is, when I copy this formula, I don't want this to move. I want this to be an absolute cell reference, right? There's no reason for me to want that box to move left or right, up or down, right? So I want to lock in both ways that it can move, right? By putting $ signs in front of the G and in front of the 6, right? So lock in the column, lock in the row, And then I can hit times, right? And then I want to multiply times the interest, right? So the interest for this row is the cell B4, right? So I can hit that, and it will multiply those two things together, right? So in general sense, in these rows, I want to take the periodic rate times whatever is in the balance row, right, for that column, right? So I can hit equals, and I get my $10, right, which we calculated earlier for the first month. And then so the new balance is going to be the balance at the beginning plus the interest, right? So I would hit equals balance plus the interest, right? And I'm going to want these cells to change as I fill down, right? Because you'll see in a minute, right? If I'm looking at this row, right, month 7, to calculate this balance, I want to add this cell plus this cell. So I want this trait to pull down as we go along, right? So you want to be careful in this step though, because I can't just pull everything down at this point, right? And the problem is this cell B4. If I were to pull this down in this fashion, right, what's going to happen is it's pulling the next number down, right? So I was referencing cell G1. Now it's pulling in the cell G2. So I don't want that to happen, right? I need to connect the month 1 to month 2, right? So if I hit equals and then I click on cell D4, right, that's what I want to reference, because in month 2 I now have a balance of $1,010, right, not 1,000. So if I link those in, it's going to pull that correctly, and then now I can pull both of these down and it should calculate just fine, right? So to double check, I can double click in here, and this is what I want to happen, right? Take the periodic rate times the balance, right? That gives me the interest. And then to get the new balance, right, I want to add these two together, the balance and the interest, which it's doing just fine, right? So now it appears that it's probably working okay. So I can highlight all three of these boxes at the same time to pull all these down at the same time, right? So now it should be calculating everything correctly, right? And here in this gray box, right, it's just a note that can be useful. So let me demonstrate that. So since I already have this column here of month 3 through 12, Excel recognizes that I'm going to want to fill down to this to the end of where I stopped entering numbers, most likely, right? So if I highlight these and then I double click on the fill down, it's going to pull it down all the way through month 12, right, automatically. So that can just make it convenient, a convenient feature to use, right? All right, so let me fill these in, right? And again, caution is when you enter a formula for Excel, make sure you always start with equals, right? So the formula that was in C4 was equals. So we had $, G, $, 6, right? Times. So we showed times in Excel with an asterisk, right? Times B4. Right? So that was for cell C4. So let me grab a different color for D4. So in D4, the formula that we had was equals B4 plus C4. Right? We wanted to add the balance with the interest. Right? Oh, let me X out of that. Sorry about that. Right? So so those were the formulas that we had in those cells. So then in number 7, it says which formula involves an absolute cell reference, right? So remember, if you look up here, absolute cell reference, it has a $sign in front of both. So the formula that had an absolute cell reference was this guy, right? So we could just copy this down here, and that's the formula that has the absolute cell reference, right? Here, this has relative, right? Relative cell referencing. Right, so just to get some practice with that terminology. Right, so if I flip the page to number 8, it asks, why do we need to fill in the second row before we fill down the formulas? Right, so something you could write is we need to link the beginning the beginning of month 2 to the end of month 1. Which are the same value. Right? So when you're doing a table in this fashion, like an amortization table, it's important to do the first 2 periods, right? So that way we can link the end of the first period to the beginning of the second period, right? Because those values are going to be the same, right? So that's what we're demonstrating. So then number 9 says, what do you owe at the end of the first year, right? So at the end of the first year, at the end of month 12, this cell, which I'll highlight in red, right? This is how much we owe at the end, right? So for number 9, we would just fill that in, right? So it would be $1,126.83, right? So this is how much we would owe at the end of the first year, right? Just for getting out a $1,000 loan and we made no payments. So then number 10 asks, what is the APY, right? So if you remember from the text, and also I think it was mentioned in a couple pages ago, right, with the definitions, right? APY, so it says this in words, but I'll put it out of formula. So APY is equal to the total interest from the year divided by the original principal. Right? So the total interest for the year would be $126.83, right? So the interest is how much we paid above and beyond the $1,000 we borrowed, right? So this one's easy enough to see that we paid this much more, right? So if I take this and subtract off 1,000, then I get the interest, right? Because this is my principal, right? So we have $126.83 paid in interest, and the original principal is 1,000, right? So we would divide by 1,000. So in doing so, if you divide that, you'll get 0.12683. And typically with APY, we demonstrate that, we show that as a percent, right? So this translates into 12.683%, right? Remember to go from decimal to a percent, you're going to move the decimal spot 2 spots to the right, right, to put that into a decimal, right? All right, so that's all of this worksheet. So if you have any questions, make sure you email me, post to the discussion boards. I'm happy to help, right?